Welcome back. We are sort of done with 2/3 of the course. Now we start with week 8 and we'll complete the remaining 1/3 of the course. Last week you learned something that is trending, that is tough. To compensate for that, this week we will take a completely new approach and learn a whole set of easy software testing techniques. Till now, we did graph-based testing, logic-based testing, and symbolic execution, techniques that are predominantly used for white box testing. This week, we're going to look at the opposite, namely black box testing. Black box testing, test case design techniques. Black box testing looks at code as a black box and is designed purely based on requirements, inputs, and outputs. So before we get started with understanding common test case design techniques for black box testing, it will help to spend one lecture understanding what software requirements are. Of course, in the companion course on software engineering, you would see this in a lot more detail, but mine is mainly an overview to help you get started with appreciating requirements to design black box testing test cases. So we all know software development lifecycle. You have learned it again in the software engineering course and in the first week in this course. This is just a slide that I had used in the first week. I'm putting it again. The whole life cycle, which starts from conceptualization, writing requirements, design and architecture, coding, unit testing, system testing, release and maintenance, that results in a high quality software, constitutes software development lifecycle. Broad activities we just saw: conceptualization, planning, definition of requirements, one of the very early activities, design and architecture, followed by coding and unit testing, then putting the components together, integration, system testing, post-release, maintenance of software. Whatever model you use, these activities are going to repeat in some way or the other, in some order or the other. The focus of this lecture is to look at requirements and understand the various kinds of requirements that come into picture and what role will they play in terms of designing test cases. This is the definition as per the IEEE standard glossary for software engineering terminology. I had referred to the same definition right in the first week. So the glossary is 610.12, dated 1990, old, but some definitions don't change. So a requirement is defined as follows. So there are stakeholders, which are basically users of your software. So it's a condition or a feature or a capability that is needed by a user or a stakeholder to achieve something. They are using the software to achieve a purpose, to get their work done. It is also a condition or a capability that must be met or possessed by a solution. For us, the solution is a software. For that solution to satisfy a contract, a standard, a specification, which is synonymous with requirement, and other things. A documented representation, a written representation of one of these constitutes a requirement. We will focus on specifically software requirements, but even there could be of several different kinds. So there are several classifications of requirements that are available. This is one kind of classification. So broadly, a requirement could be classified as a product requirement or as a process requirement. A product requirement describes the properties of a product or a system. It can be a software product also. In fact, we are focusing on software product. Just to contrast it with, like, for example, let's say a dentist would use that full dental equipment machine, which is a product. We might end up using fridge or a microwave at home, which is a product. They all might contain software, may not contain software, but for us, a product is essentially predominantly software driven or purely a piece of software. So examples of such product requirements could be like this. Let's say a phone manufacturing company is manufacturing mobile phones, and they have a requirement about the whole product, the phone itself. It should be available in metallic colors of some variety. Could be a product level requirement for a mobile phone. It should be available in flip mode. It should have so many cameras. All these could be product requirements. Another kind of product requirement is, let's say, in cars, we all press this button to let the window glass go up or go down. Those are called power windows. So one safety feature, which is also a product requirement for the car or for the power window in a car, which is controlled by software, is that if there is an obstruction, right? Let's say a child's hand or somebody throwing something. If it senses an object, then the moving window should stop moving. So this is a product requirement which is of the safety kind. So requirements can be broadly classified as product requirements or as process requirements. Process requirements, on the other hand, contrast to product requirements, describes the activities or the methodologies or the processes to be followed by an organization that is involved in product development. Like, for example, if you take the same power window in a car, there are regulatory standards that it should meet. So the company that is developing this power window, including the software, will have to adhere to certain processes through which they can get their software certified for meeting the regulatory standards. So that is process requirements. This is one kind of classification of requirements that is useful to keep in mind. Another kind of classification tries to classify requirements based on their types. Requirements could be related to business, could be related to what the users want, could be functional requirements, or could be quality or non-functional requirements. There could be regulatory requirements, and so on and so forth, based on the domain, based on the development of software. Almost all these requirements are used and defined as a process of software product development. And the documents that contain these requirements usually have this tag RS. Like, for example, functional requirements. Document that contains all the functional requirements will be called as FRS. Sometimes you write down software requirements exclusively to the software. So that will be called as SRS, software requirement specification. So most of them are referred to as XRS, where X is substituted with the appropriate kind of requirement. So we'll walk through one after the other briefly. Business requirement. It's basically, these are requirements that specify the characteristics from the viewpoint of a user or a stakeholder, from a business point of view. So the document where these things are written are called STRS, short form for stakeholder requirement specification. One kind of business specification, for example, in the mobile phone market to achieve a good business share is that charging must be really fast within a certain specified amount of time, and the fully charged phone battery must last for really long. So this is one of the selling features or business features for a mobile phone. Similarly, you could have another kind of selling feature which talks about the availability of the phone in trending colors, metallic, non-metallic, things like that. So these are business requirements. As it is, we may not develop test cases for these requirements as a part of a course like this, but these are tested for in different ways. The other kind of requirements are user requirements, which specifies typically they are similar to business requirement. Here, the focus is on the user, what the user expects the software to be able to do. The document that details the user requirements is called URS, User Requirement Specification. It is basically like an agreement or like an offering that talks about what the software must do from the point of view of a user. Let's take mobile phones in India. One important user requirement is the availability of FM radio. So most phone manufacturers provide that as a user requirement because phone users use mobile phones for that. The next could be that language interface of the phone should be available in all predominant Indian languages. Somebody might be comfortable with English, somebody might be comfortable with Hindi, somebody might be comfortable with Kannada, somebody might be comfortable with Gujarati. The user interface should be available in all these languages because it helps users from different states who have different language preferences to be able to use the same kind of phone. So these are small examples of user requirements. Again, we may not develop algorithms for test cases for these, but this is just to give you an idea of what a user requirement is. This becomes important for us, namely functional requirement. It talks about what a system or a part of a system or a software is supposed to do in terms of its functionality. That is, if it gets such an input, what is the output that it should provide? It describes specific particular behavior or results of the system in terms of an input-output relationship. For example, let's say our Indian Railways does provide an online ticket reservation system, IRCTC. One simple requirement is if a senior citizen is booking his or her ticket through that system, then the government commits to providing tickets at concessional rates for senior citizens. So the online booking system, which is the software, should provide the concession rates for passengers who are senior citizens. So if the input says the passenger is a senior citizen, age above 60, the concession should come in the fare that is computed for the passenger to pay while booking his or her ticket. So this can be thought of as a functional requirement. And the other kind of functional requirement is that for payment after online booking, the software should be able to take payment through several methods: credit card, debit card, UPI, and so on. So typically functional requirements are specified in a functional requirement specification document. They can also be given as use cases, UML use case diagrams, activity diagrams, and so on. In the software development lifecycle, after the requirement stage, we do design and architecture, and software design is what caters to meeting all the functional requirements. We will develop test case methodologies, that is black box in nature, for testing functional requirements. The next comes non-functional requirements. This is contrast to functional requirements. It specifies criteria that can be used to judge the operation of a system rather than it talk about its behavior. Functional requirements typically say what a system is supposed to do. Like for example, here, online train reservation system should provide concessional fare to senior citizens. It's one functional feature of a system. In opposite to that, non-functional requirements say how a system is supposed to be or exist or behave. These are specified using quality parameters. How is the security of the system? How reliable is the system? How usable is the system? What is the performance latency of the system? How easy is it to maintain the system? What is the availability of the system? So all these things correspond to quality parameters. We will have one lecture specifically on software quality parameters also. Examples of non-functional requirements are things like this. Suppose a user sends a request, the response should come within a second. Suppose I am accessing a bank online portal, type in my username and password, it should give me the welcome screen within a second. So this talks about how fast the system should be in terms of its response time. The other kind of example could be related to non-functional is, at a certain point in time, there could be a large number of users using a system. The system should not slow down. It should provide details to all these users simultaneously logging in. So this is another example of a non-functional requirement. Requirements can also be regulatory requirement. Like for example, I told you, right? Suppose I manufacture the software that controls the power window controller in a car or the airbag release system in a car. This is a safety feature. The software needs to be certified to meet certain regulatory requirements. Similarly, suppose I develop a software that talks about patient data in a hospital, there are lots of regulatory requirements related to security and privacy of data, which the software needs to be certified for. So regulation is the management of system or software as per a set of rules, laws or regulations that can cater to several different factors: laws that govern environment, laws that govern the business domain, laws that govern safety of operations, safety while use, and so on. Regulatory requirements also differ from one country to the other. This is again not within the scope of our testing. What we will test in this list of requirements or the algorithms for test cases that we will develop are those that involve functional requirements, which is going to be the focus of this week. And later, briefly, we will do a module on quality and non-functional requirements and what are the testing goals related to non-functional requirements. So why are we doing requirements? Because the next module that we're going to do, that is the 4 modules of this week, are related to black box testing. And requirements are the only important documents that we will use for designing black box test cases. To recap, which we saw from the first lecture, black box testing deals with requirements. It spans all the variety of requirements that we sketched just in this lecture. And test cases are designed in a black box style, in the sense that the test cases are executed on code, which is the executable entity. But we don't look at the code or its structure or its design. We treat it as a black box. Like, for example, we don't look at the code to draw its control flow graph. We don't look at the code to find out what are the logical predicates that label the decision statements. We treat the code as a black box. Focus our energy on the requirements. A requirement could be specific to a piece of code, specific to a method in a code, specific to the entire software. Could be several different kinds of requirements, most of them functional in nature. And then we design test cases by looking at these requirements, functional requirements, the inputs, and look at the expected outputs, come up with expected outputs. Test cases designed this way will be black box in nature because they're not going to look at code. And the focus of this week is to understand the most popular black box test case design techniques that exist. So I'll stop here for now, which is a brief overview on requirements specification, the kinds of requirements that we will deal with software. In the next lecture, we will start looking at functional requirements and at functional testing. Thank you.